Hi all, my name is Jonathan Hopper and you join me live in my biology lab where we are about to talk about osmosis. You see, I would characterize osmosis as the flow of water through a semi-permeable membrane like your cell membranes in response to what we would call solute concentrations. When there's a lot of solutes, like salts or what have you, inside of a cell, then water wants to rush in and join with those solutes. Whereas, if I were to put a cell in an environment where there are a lot of solutes outside the cell, the fluids in the cell would want to leave. This gets lumped into a concept commonly called tonicity. When I say tonicity, I mean being isotonic, hypotonic, or hypertonic. A cell in a hypotonic solution will get larger because water is rushing into the cell, because in a hypotonic solution, there's more solutes in the cell than out, so water rushes in. In an isotonic solution, there's a balanced amount of solutes into and out of the cell, so the cell stays roughly the same size. And comparatively, if you place a cell into a hypertonic solution, the cell will shrivel up as the water leaves, chasing solutes on the outside of that cell. And I can show you this with great clarity. Here I have a number of setups from earlier today. This is a cell that we made out of what's called dialysis tubing. Dialysis tubing, though you can't see it, it has little bitty holes all in it. So fluids and other products can move through this if they are small enough. This particular cell contains water, and it is in a beaker that is also containing water. So even though this was set up in this beaker 8 hours ago, and it weighed 11.6 grams, at this very moment, it still weighs in at approximately the same value because it can't really change much weight because it's a water cell in water. That is isotonic. Comparatively, this is a beaker which contains water, and this is a cell that was produced which contained 40% sucrose solution. And look at this thing after 8 hours. It's ready to pop. It's about to physically explode. When this was set up, it weighed 11.6 grams, but look at us now. Oh my gosh, almost 17 grams. The idea is this thing is swollen up and about to pop. This would be a hypotonic solution, right? A hypotonic solution. So there are more solutes in the bag than there were in the solution. So the water chased the solute into the cell, causing that cell to swell up and get all big. A hypotonic solution. And last but not least, I have this beaker. This beaker contains fluid which is in fact 40% sucrose. And the cell inside of here, the bag that was made, the facsimile of a cell, contained nothing but water. So there's water in the cell, and the beaker contains a high sucrose solution. That environment is very much hypertonic. So the water in the cell has left. This has been sitting for about 7 hours. Yet again, when it was first made, it weighed about 10.4 grams, but look at it now. Oh my gosh, there's virtually nothing left. Because yet again, this is a very much hypertonic solution, causing this cell to get very small indeed. So while it started out at 10.4 grams, it's currently at 4.7. And we got a mess on our hands, but the point stands. Cell in a hypotonic solution has gotten larger. Cell in an isotonic solution has not really changed weight. Cell in a hypertonic solution is virtually gone. We'd call that crenation in a real situation, whereas here we would say this was about to go through hydrolysis. Hydrolysis is about to pop. And we can very easily graph this. So this is delta W, that's change in weight. This is delta T, that is change in time. If our value never changes, if it stays flat over time, that cell would be in an isotonic solution. If the weight goes up, that would be a hypotonic hypotonic solution. And then by comparison, if the weight goes down, that would be in a hypertonic solution. Hypertonic solution. Yet again, hypertonic, there are more solutes outside the cell. So water leaves the cell to join those solutes. Isotonic, equal amounts of solutes in the cell versus out, so the weight stays the same. Hypotonic solution. The cell will have more solutes than the solution, so water from the solution runs into the cell, causing it to get larger and heavier. And that'll do it, folks. Thank you so much. I hope you better understand tonicity. Have a wonderful, wonderful day.